Okay, class, we're about to start the second part of lesson 9 from chapter 6. It says sloping unit rate. The unit rate is a way of showing the relationship between two variables as the ratio of how many units of one quantity there are per one unit of the other quantity. We're on page 372. Unit rates are used constantly in everyday life, as well as in business, science, and the trades. On a given day, you might go to the butcher for a cut of meat that costs $2.89 per pound. Merge onto a highway where you increase your speed to 55 miles per hour and compare LED and fluorescent light bulbs at the hardware store, seeing that the fluorescents using an extra 1.8 kJ of electricity per hour. Each of these everyday ratios compares two quantities, and the second quantity given per this is what would be represented by the x-axis of a graph. The unit rate, the quantity of y per 1 unit of x, is the same as the slope of a line representing the relationship calculated in the previous lesson as rise over run, with one difference. The unit rate is typically expressed in whole numbers or decimals rather than left in fraction form. So in this case, when we're doing the unit rate for this graphing, we're going to write it as a whole number or a decimal and don't leave it as a fraction. Okay, let's take a look at example 1. Now with example 1, it says the coordinate grid shows the cost of gas at a particular station. Avery and Beatrix partially filled 2 jerry cans separately and later graphed the values from their receipts to determine the relationship between cost Y and gallons of gas purchased X. Determine the cost of gas from the coordinate grid. Now if you look here, cost is our Y values. So if you look at our Y values going up, remember we do rise over run, and we know rise deals with the Y values. To go from 7.5 to 12.5, we know we would go up 5, because 12.5 minus 7.5 is 5. So that would be our rise. Our run, we would look at our X values. We have 5 minus 3, which is 2. So that means we go over 2. So our rise is 5, and our run is 2, which we see here. So 5 divided by 2 gives us 2.5. Now, we would stop here because the directions told us that we would leave this as a decimal or a whole number. But in this parenthesis, it says this is the same as saying that the ratio is 2.5 over 1. So under normal circumstances, we would have the 2.5 over 1. But in this case, they want us to just have the 2.5. Now, number 3, it says interpret the meaning of the rate as determined by the slope. The cost of gas at the station is $2.50 per gallon. So that means this is 2.5 per 1 gallon like we would have here with the fraction. But since we're not showing the fraction and we're using dollars, this would be $2.50 per 1 gallon or per gallon. Okay, now we go here to the next one. We got problem number, we had note. You may have noticed that in this example, you can get the same answer by dividing 7.5 by 3 or 12.5 by 5. This works because there is an implied third point in the proportion or relationship. When you buy 0 gallons of gas, the cost is $0, meaning 0, 0. So don't worry about this little note here. Okay, now example 2. It says the technology company follows a predictable pricing trend, where the price of a new product decreases linearly over time. The company releases a new smartphone at a retail price of $680. Now it says the following graph shows the cost of the phone for the next 5 years. It is on the market as cost Y versus time in years X. Okay, so now we want to figure out our rise over run. So if you look here, we look at our Y values. Now if you notice going from left to right, you notice this line is going down. So that means that our slope would be negative based upon what we learned earlier. So if we just take any random 2 points, we took these 2 points here. We know 625 minus 680 would give us a negative 55. And 1 minus 0 is 0. So it'd be a negative 55 over 1, which is a negative 55. Now, what we could do here is, or we could take two ordered pairs and find the slope. So let's do that. And I'm going to write this down as example 2. So I'm going to take those first 2 points, that's 0, 680, and also the 1, 625. And we know our slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we know here that this ordered pair, that this would be x sub 1, y sub 1. This would be x sub 2, y sub 2. So now we can substitute. Y sub 2 is 625, and y sub 1 is 680, all over x sub 2, which is 1, minus x sub 1, which is 0. 625 minus 680 is a negative 55. 1 minus 0 is 1, so it's negative 55. So your slope is a negative 55. So as we see here, it says, interpret the meaning of the rate as determined by the slope. The smartphone model drops in price by $55 every year it is on the market. So what you would say is, like they said, the drop in price will be $55 per year. Now, if you notice here, when we're writing out the explanation, you notice that we don't put a negative with the 55, but because we say that the drop in price, we know automatically that that's a negative 55. So now, let's go down here. We can skip this next example and go right to the problems. Now, we're actually on page 374 because, as you see, some of my copy did not come out good. So it's a little blurry, so you may have to look in your book. But we look here at A. It says, use the slope formula to find the rates that correspond to the numbers in these scenarios. I want to do number 3 first because I believe that when we do number 3, it'll make problems 1 and 2 a lot easier. So starting with number 3, it says a scientist is looking for the relationship between the x and y variables in the experiment, and she collects the following data. If you notice here, she has 3 points. Determine the rate of quantity y per unit of quantity x. So what this is saying is, you always, whenever they tell you what they want, when they say here, the quantity y per unit of x. So what it is, your y values is what determines what goes here, and your x values determine what goes second. So if we go to number 3, we could pick, well, let me put down all of the ordered pairs. Now all we need to do is pick 2 of these 3 ordered pairs in order to find the slope. I'm going to go with the first 2. So this would be my x1, y1. This would be my x2, y2. So we have the slope formula up here. If you want to rewrite the slope formula, you can. So y2 is 6.4 and y1 is 2.4. x2 is 8 and x1 is 3. 6.4 minus 2.4 is 4. 8 minus 3 is 5. Now 4 divided by 5 would give you 0.8. So your answer here would be 0.8. Now what I want to do, I'm going to go to the back of the book to see whether or not they had you all write this out in a complete sentence. And they did. So your answer here would be 0.8 units of y per unit of x. So that'll be number 3. And I'm going to show you when we get down here to 1 and 2 how number 3 helps with 1 and 2. Now with number 1, it says A catering company orders 150 pounds of fresh clams for a banquet serving 100 people, and 30 pounds of clams for a dinner party of 20 people. Determine the standard number of pounds of clams per serving. Okay, now, so they want pounds to be your Y value. Remember, I told you your first value, which would be pound, is your Y. The servings, the per after the per is your X. So when we write this out, that tells us, remember, Y is always second. So that tells us even though the 150 pounds came before the 100 people, the 150 pounds would be second and the 100 people would be first. And the same thing here. The 30 pounds would be second and the 20 people would be first. That's how number 3 helped, because it tells you that Y goes in the ordered pair second, and then the X goes first. So now this is X1, Y1. This is X2, Y2. So we have the slope is equal to, we know Y2 goes first, minus Y1, which is 150, all over X2, which is 20, minus X1, which is 100. 30 minus 150 is a negative 120. 30 minus 100 is a negative 80. Now, negative divided by negative is positive, and then you have 120 over 80, which will give you 1.5. Now, you can put that in your calculator, or you can use the division that we used in the those past lessons that we've had. So now we have to write out a solution here as far as the number sentence. Okay, so with that being said, we would do this here. We would say it's 1.5 pounds. Now we could spell out the word pounds, or we could just write the LBS. It's 1.5 pounds of clams per serving. And that is your final answer. Now we go here to problem number 2. All right, number 2. All right, it says a painter uses 15 gallons of interior paint to cover 300 square yards of wall and ceiling space. On a different job, he uses 8 gallons to cover 160 square yards. No paint is left over on either job. How many gallons of paint are needed to cover 1 square yard? So if you notice here, gallons is your Y value. So gallons would be 15 here, which would be Y, and then the square yards would be first. And then here, gallons is 8, and the square yards is 160. All right, now, so we have the slope is equal to Y sub 2, which is 8, minus Y sub 1 is 15, all over X sub 2, which is 160, minus X sub 1, which is 300. 8 minus 15 is negative 7. 160 minus 300 is a negative 140. A negative divided by a negative is a positive. So we will have 7 over 140. So this right here is actually, when you simplify it, it'll be 1 over 20, which is basically 0.05. So then we would say that it is 0.05 gallons per, what's that, per square yard. All right, now, so that is our final answer. So now we move on. All right, so now all right. So with problem number 4, I'm going to leave myself enough room here. So I do 0. We know that pounds goes here because The question says with number 4, oranges are on sale for 44 cents per pound. Draw a graph of cost Y per weight of oranges, X. So we know pounds is your X value. So I'll go 1, 2, 3, 4, 5, 6, 7. All right, so those are the pounds. Now we do cost. Cost we know would be our Y. All right, so now, since we know it's 44 cents per pound, what I like to do, I just like to use the numbers that's given us. So I do the 44 cents, and then I double that and make that 88 cents. And then triple that will be at what, $1.32, I do believe. Yeah, $1.32. And then this would be $1.76. And then let me see, $2.20. And then this would be $2 and what's that? 64 cents. Okay, I'll stop here. Okay, so now, so for 1 pound, it'll be 44 cents. So we'll put that here, 0.44. Then 2 pounds, it'll be 88 cents. So we add 2, 0.88. 3 pounds, it'll be $1.32. Should be here, 3, $1.32. Then 4 pounds, it'll be $1.76. So we have 4, $1.76, and so on. So that will give you a good idea of what this graph is supposed to look like. Now, we go here to number 5. It says a vintage vinyl record player spins at a rate of 78 RPM revolutions per minute. Draw a graph of number of revolutions per time, X, plotting points for a 3-minute, 4-minute, and 5-minute record. Okay, so they specifically give us what our graph is supposed to be like. So let me do this real quick. So we're going to draw a graph. I'll scratch that out. Okay, so if you look here for this graph, first of all, we know we have 0. Okay, so now you have 3, 4, and 5. So it's for plotting points for 3, 4, and 5 minutes. So we'll go 1, 2, 3, 4, 5. Okay, so we have our minutes. So this is our time. So time, we know it's in X minutes. Okay, now down the side, we do the revolutions. So if you notice, it's 78 RPM revolutions per minute. So we'll start off with, well, we'll do this. We'll do revolution, we'll put RPM, and then we'll put Y and revolutions per minute. Okay, now, we know that the first would be 78. The second would be 156. Then we can add another 78 here. What's that, 234? Then we add another 78. Let me see. Look like 322. Wait a minute, no, is it 312? 8. Yeah, it's 312, not 322. So it's 312. And then another 78 would be 390. Okay, so we can stop there at 390. All right, so with that being said, we graph this. Now, one thing that I didn't graph, and let me go back up here. We could put at 0, that point would be 0, 0. And then the same thing here at 0, it'll be 0, 0. Okay, now, we go to 1. This would be 1 and 78. I mean, technically, we don't have to do 1, 2, or 3, but I'm just doing it for practice. So then 2, we'll go to 156. So we add 2, 156. 3, we'll go to 234. So 3, 234. 4, we'll go to 312. So you have 4, 312. That's one of the ones they wanted you to do, and 3 was 2. And then now we would go to 5, and then that'll be 390. So 5 and 390. So this is our graph here. And you notice it's a linear line. Okay, now we go on to the next page. Now on the next page we have C. It says, given the following graphs, determine the rates. Question 6 refers to the following graph. Okay, when we look at question 6 here, it gives us this graph. It says, a telemarketing company tracks its employees' efficiency. Use the graph to find the rate of calls per hour of work. Okay, so basically, we could take these 2 points here. This is problem number 6. We have 0.00, and then we have 0.473. And all we're doing is mainly just interpreting the slope. So we would have y sub 2 is 73, minus y sub 1 is 0. X sub 2 is 4, minus x sub 1 is 0. 73 minus 0 is 73, and 4 minus 0 is 4. Okay, so now, we could do like we did. You could take out your calculator, or we could just divide here. 4 goes into 7 one time. 7 minus 4 is 3, bring down our 3. 7 goes into 33 8 times. 8 times 4 is 32. 33 minus 32 is 1. We'll bring down our 0. 4 goes into 10 twice. 2 times 4 is 8. 10 minus 8 is 2. Add a 0. Bring down your 0. 4 goes into 25 times. So you have nothing remaining here. So your answer here would be 18.25 calls per hour. So it's 18.25 calls per hour. And that is actually C. All right, now we move on to problem number 7. It says question 7 refers to the following graph. Okay, we see this graph here. It says on 3 carpet installation jobs, a contractor records the values above with the goal of analyzing whether her rates are high enough given the time it takes her to install carpet. It takes her 1 hour to collect tools and drive to a work site. The x-axis shows square yards of carpet, and the y-axis shows hours spent. What is the rate of time per area installed? So what we have to do, we could take these ordered pairs. So what I would do, I would take the 2 lower numbers, which would be 4, 1.5, and then 100, and 2.25. So now we add a slope. We'll take y2, which is 2.25, minus y1, which is 1.5, all over x2, which is 100, minus x1, which is 40. So 2.25 minus 1.5 will give us 0.75. All over 100 minus 40 is 60. Now, we could divide this out. We add 60 into 0.75. We'll bring up our decimal. 60 goes into 0, 0 times. 60 goes into 7, 0 times. 60 goes into 75 once. 75 minus 60 is 15. Add a 0 here. 60 goes into 150 twice. 2 times 160 is 120. 150 minus 120 is 30. Add a 0, bring down your 0. 60 goes into 300 5 times. 5 times 60 is 300. So our final answer here is 0.0125 hours per square yards. And that would be A. So that finishes up the second part of lesson 9 of chapter 6. So have a wonderful day, and I will upload this to YouTube.